section G can be a little tough to visualize at first. So this sundial is kind of a good way to think of it. Think of the sun being directly overhead. The shadow directly underneath is called a projection. And what we're going to do is find the angle between a line and a plane and its projection onto the plane. All right, so let's first start with just finding the projection and what the angle would be that we would look for. All right, so first of all, we're going to just connect. Let me just do this. We're going to connect P to U. Now notice this is kind of like on the back. This is on the back here. So if the sun were directly overhead, can you see if I project it down onto the base plane, kind of onto the floor, think of the floor, that this would be on this particular, that's where the shadow would be. It's directly underneath it. Now, what angle connects PUT? That's the angle between the following line and the base plane. So, angle PUT. We start with the top, go to the U, make sure this is the angle in between. All right, here's X. So let me clear off the work from letter A. So if I want to go from Q, okay, that was bad. From Q to X, how does that fall? What would be the projection? What's directly under Q is U to X. So what is this particular angle? Angle QXU. Okay. Now we're going to actually, if you can visualize the angles, now we're just going to actually find the angles. All right, so this says that this is 12. It's a cube, so all sides are 12. So find the angle between the line segments and the base plane. So first we have to visualize from A to H. Goes from here to here. All right, so where's the projection? Straight underneath is E to H. So this is my angle that we're looking for. Well, in this particular projection, this is on the face, on the front face of the cube, so that's a right angle. So in my right triangle, this is my opposite and my adjacent. So tangent of my angle equals 12 over 12, which is just 1. So theta will be tan inverse of 1, which is 45 degrees. So the measure of angle AHE is 45 degrees. All right, the next one's a little trickier because it's going across the plane. So I'm going to clear off my drawings. All right, so now I'm going to go from B to M. So then we can see my base projection goes from F to M. So then this is my angle kind of going through the middle of the room, so to speak. All right, the first thing we start with, I need to know a couple of things. I know this back side here is 12. Now I need to find this length here, and that will be a right angle. So what we do, I'm going to use the floor because this is a right angle on the bottom. Think of the bottom corner of a room. So if I draw this out, this is three-dimensional, so it doesn't look like it, but that's my right angle kind of in a corner. Where this is 12, this is the midpoint, so this is 6. So I can find this side by doing, this is my hypotenuse, a squared plus b squared equals c squared. I'll just say h squared because that's the hypotenuse there. So when this is 36 plus 144, add together 180. I'm going to leave this as the square root of 180 because that's more exact. All right, so to find this angle here, now I'm going to use this as my opposite. This is my adjacent. So we're going to go tangent of my angle equals 12 divided by square root of 180. So take tan inverse of 12 divided by the square root of 180. And my angle should be 41.8 degrees. So that's the measure of angle BMF is 41.8 degrees.